all. So I've got some of these new strain gauges that we've got from our Advanced Sensors group, and we've got a workshop coming up this summer that's a composites class, and since these are new, I'd like to work them into the composites class, and I decided I would instrument one of these small composite beams using one of these new gauges. The strain gauge, if you look at the part number, it starts with C4A and then a -06-125SL-350-39P. And what that represents, the C4A is a construction of the strain gauge. That tells us that it's a pre-cabled gauge and it's got constant tan foil. The 06 is the temperature compensation. This one is temperature compensated for steel. We're going to be testing a piece of G-10, which is basically fiberglass, which has an expansion rate relatively close to steel, maybe a little bit higher, but we're testing it at room temperature, so it doesn't much matter. The next part of this part number is the 125SL. The 125 is the active gauge length in thousandths of an inch, so it's an eighth of an inch long, or 0.125 inch active length. SL means it's a linear pattern, 350 is the resistance, and then here at the end is 39P. And what that represents is the cable that gets pre-attached to these gauges. It's a 3-conductor, 9 feet long, pre-cabled strain gauge. If you look at some of the other data that you see here on the data sheet, you got the resistance, which is 350 plus or minus 0.3%. Temperature coefficient of gauge factor runs about 1.5%, which is real common for constant tan alloy strain gauges. Gauge factor is 2.09, and of course we're going to need to use that when we get ready to connect it into a strain indicator. We've also got the transverse sensitivity, spec'd at 0.9%, just under 1%. And then these are the coefficients for the thermal output. This gauge is matched to 1018 steel, and this is a fifth order polynomial that will match the characteristics if we were to take this gauge and glue it on to a chunk of steel. And of course, last but not least, you got the foil lot number for that particular strain gauge. The packaging of these is a little bit different. These come in a box with 10 gauges. We've already used a couple of these strain gauges already. I'm going to open up the box, and just to kind of show you, I'll take it out. These are in a little small red envelope. And you can see that the strain gauges are inside of a folder just like normal. You can see the active grid area here and the solder connections, very neatly done, very tidy, very good looking strain gauge. And one of the best things about it is that you can take this gauge, glue it onto the composite, and you don't have to do any soldering at all. So basically, once you clean the surface, get the gauge installed, and maybe put some environmental coating over top of it, basically after that you're done and you're ready to start testing. So that's what we're going to focus on now. We're going to take this and kind of move it to the side, and we'll get started on the surface preparation for this G10 material. If you look at it kind of closely, you may be able to see this in the camera with the light reflecting. And when it does that, it means that the surface is quite smooth. So what we're going to do is use M-Bond 200 to glue the strain gauge on. If the surface of this composite had a little more texture to it or a little bit rougher, I would probably use a 2-part epoxy for that. But this is just going to be a short-term measurement at ambient temperature in a controlled setting. And again, the surface of the G10 is quite smooth, so I'm going to use M-Bond 200 to glue the gauge on. If I were finding that this surface was rougher, again, I'd use a 2-part epoxy. A very typical one that we manufacture is a material called M-Bond AE10, which is a 2-part material. You mix it up and you got about 20 minutes to use it, but it has a much higher viscosity than this cyanoacrylate. And basically what that means is that it would be a better filler material, and also it would last longer if you were testing a composite structure where you wanted the gauge installation to last for maybe many months or many years. You'd really need to use a 2-part epoxy for that. But for this short-term measurement in a laboratory setting on a smooth surface, we're going to use the M-Bond 200 with the adhesive and the catalyst. Now, that being said, we're going to get started with the cleaning, and the first thing I'm going to do is degrease it with some GC6 alcohol. So I'll just take the cap off of it, locate one of these gauze pads. I'll put the alcohol into the gauze pad, and then I'll just wipe off both surfaces of this G-10 beam. And you're just trying to get off any oils from folks picking these things up and handling them, or when they were being machined or cut into a coupon. We're just trying to, just wipe off both sides, get the vast majority of contamination off. And once you've done that, basically now you pick a side of where to put the strain gauge. And now we're going to focus on a light abrasion. We're going to put the gauge here in about the center. It's not real critical for this experiment, but we're going to put the gauge here about in the center. And before we get to that, we still got some additional cleaning steps. And next thing I'm going to do is to abrade it using a 400 grit silicon carbide paper. Basically, it's like wet and dry sandpaper that you use for prepping the surface of a car before you were to paint it. I'm going to tear off a piece that's about 1.5 inches or maybe 2 inches long. Fold it just like that, and then just lightly scuff the surface right here in the middle of this composite. What I'm trying to do is take off some of the shine. So we're trying to add texture. And some folks will abrade back and forth in one direction. You could cross hatch if you want to. That can help to add a little bit more texture, especially if you're expecting very high elongation. I would lean you towards cross hatching. Here for this, for a pretty simple static test, just sanding back and forth straight is usually fine. And if we want to take a look at it, you can see now that the surface is kind of dull. And that's what we're chasing after. We want to see that dull surface. Now the light's going in a bunch of different directions, and that matte finish is what you're chasing after. You don't want to see something real shiny. So once we've done that, the next step really is to scrub it. And what we're going to use some conditioner. This is a very mild phosphoric acid. It's just going to be an additional cleaning step. It's a metal etchant. If you've got materials like steel or aluminum, not only it's a cleaning solution, but it also helps to etch. Here, basically, it's just going to be a cleaning solution since we're on a non-metal surface. Just put a few drops on. Take a cotton tip applicator, and then I'm going to scrub the area in the middle of the beam. And scrub it back and forth. And then once I've done that, I'm going to take a gauze pad, and if you watch, I'll take it and fold it, and then fold it again. Start inside the cleaned area. Use a single wipe, and then take it and refold it and try to start at about the same location and go in the opposite direction. So to summarize, we've degreased it, we've abraded it using the 400 grit paper, we just scrubbed it with conditioner, and really the last step in the surface cleaning is to scrub it with the neutralizer. This is the ammonia-based solution. So it's mostly ammonia and water and some detergent. Shake it, take it and apply a few drops on it, and basically everywhere the conditioner went, you want this to follow. And what this will do is bring the pH back up where you've introduced that mild acid. Now you're neutralizing the mild acid, and you're also using it as a final cleaning step. I'll just kind of scrub it back and forth. You see very little contaminations being picked up because these coupons are actually quite clean to start with. Once you scrub it, take it, toss that, and then take another gauze pad, and then we'll fold it and fold it again like that, and then use a single wipe, and then I'll take it and refold it, start about the same location and go in the opposite direction. And sometimes you have enough neutralizer on there, you might need more than one, so just take another one. Start inside the cleaned area, single wipe, take it, refold it, and then make sure you're working on a dry sheet of paper. And I'll discard the top sheet or two of paper, and basically that composite is ready for installation. So the next step is we're going to focus on getting our surface ready to handle the strain gauge. And what we're going to do, we're going to find a piece, in our case, a piece of glass. If you don't have glass, you could use a piece of polycarbonate. That works as well. And you need to do a little bit of house cleaning. And by house cleaning, what I mean is we need to clean off the glass. And that's the great thing about using glass, is you can look at it and you can tell when it's got something on it, when it needs to be cleaned. And also it's non-porous. So when you put Neutralizer on it or something else on it to clean it off, it doesn't leach into it and come out later on. So I just take a couple of drops of Neutralizer, put it on it, take a gauze pad, and just kind of wipe back and forth, just a few strokes. Just like that. And now it's cleaned and ready. So not only the glass is clean, the G-10 composite is clean. So we'll take our strain gauge, and what I like to do is give myself a little bit more room. So what I'm going to do is just take the little wire holder here off and just pull a little bit more length of wire out, and then take it and put it back on there. I guess it's a wire tie, yeah, sort of like the wire tie you'd have for bread. But it gives me a little bit more room to handle the strain gauge. And what I'm going to try doing is, when I install the gauge, a lot of times when we start handling the strain gauge, we use gauge installation tape and we run it right along the axis of the strain gauge. And for most applications, that's fine. What I find though is sometimes when you've got a strain gauge that's got the wires on it, when you do that, you get a lot of adhesive that collects right around where that tape kind of interacts with the wires. So what I'm going to do is run the tape across the strain gauge. So I'll take it out of the folder and just kind of lay it up here on top of the piece of glass, and then we'll take a piece of gauge installation tape and we'll use that to position it over top of the gauge, and that'll help to control the positioning of the gauge when we take it and transfer it off the glass over to the G10 beam. And all we're going to do is put it in about the middle of that beam. Again, we're just going through a little practice exercise because we're trying to get ready for our composites class that's coming up this summer. So with that being said, I'll just take the folder off, lay the gauge here in about the middle of the piece of glass, and then I'm going to find the gauge installation tape, and I'm going to tear off a few inches of it here at the beginning of it, because sometimes you find it collects a little bit of dust as it's been sitting out. And then I'll take a piece that's about maybe 4 to 5 inches long, and I'll tear that off. And what I like to do is put a little fold in the end of it. That gives me a little handle to be able to pick it up. And what we're going to do is take this and now put it in place, and I've got really too long of a piece of tape. I'm going to take it, tack it right over top of the gauge, and kind of wipe it down into place like that. So as I transfer it now from this glass over to the composite, I'm going to turn it so the gauge is down along the long axis of the composite, and the tape will be running transverse. And then I'll peel it back just a little bit so I can apply the catalyst, let that dry, and then we'll apply the adhesive, and then we'll bond it. We'll push it over and bond it in place. So what we're going to do is we're going to lift the tape at a shallow angle, just like that. Once I get past the gauge, then I can go ahead and pick it on up. I'll take the glass and kind of move it out of the way, and then I'll find my composite. And now what we're going to do is we're going to position this gauge in about the center of the G10 material. About right there. All right, so once I've got it in position, I'm going to pick the beam up and look at it, make sure that I'm happy with the position or orientation of the gauge, and I think that looks pretty good. Pretty happy with that. And if it was more critical to get in a certain spot, then certainly you would want to mark the surface of the composite. Sometimes you can use things like permanent markers to kind of mark outside the area. You can also sand it in one direction, kind of like I did, and take a dental pick and very, very lightly with the rounded side, just lightly go across the material, and you'll be able to see a very faint line, which is enough for positioning the strain gauge. Here's not so critical, so I'm just going to leave it right where it is. So once I'm happy with the position of the gauge, I've got it, temporarily taped in place. Now what I'm going to do is I'm going to lift the tape, and that'll expose the bonding side of the strain gauge, because we have to apply not only the adhesive, but we also have to apply the catalyst. So I'll just lift the tape. Typically try not to exceed about 45 degrees, and then I'll just pull it back. Now once you have it pulled back, this will allow you, and sometimes if you take the tape and you kind of roll it back on itself, it'll kind of stick, it'll stay in place better. And then you're going to take the catalyst. What I like to tell folks is touch it on the inside part of the bottle about 10 to 12 times. You put the vast majority of the catalyst right back in the bottle. 10 or 12 or 15, doesn't really matter. But then you take it and you just use just a single wipe is all you need right across the bonding side of the strain gauge. What I find is that if you have trouble with this type of adhesive, most of the time it's due to the catalyst, because you end up using way too much of it. If you put it on and you can tell it's blue, you put it on too heavy. As soon as you get it applied, you want to start your watch and make sure that you let it sit there for at least a minute. Now, if you put it on and you can tell it's blue, you need to let it sit a little bit longer. So normally I suggest somewhere in the neighborhood of 3 to 5 minutes. You do need to be mindful if you're trying to bond strain gauges outside or in a dusty environment, that the longer you wait between applying the catalyst and putting the adhesive down, the more risk you have of getting contamination up underneath the gauge, and that's a problem. That means if you get a piece of dust or dirt or contamination or lint that's underneath the gauge, basically that means you start over again. So I got a few more seconds here to wait, so while I'm waiting, I'm gonna take a gauze pad, I'm gonna fold that and fold it again, and we'll use it like a squeegee. And then I'm going to take the M-Bond 200. I'll take the cap off of it. You only need a drop of this adhesive. Now I like to take and squeeze a couple of drops out of it that have collected in the little nozzle, just to make sure I'm getting fresh adhesive from the bottle. I've waited my 1 minute, so what I'm going to do is get that ready, lift the tape, get the tape ready. Pretty simple, pretty easy, but what I'm going to do is take a drop of adhesive and apply it right along the edge of the tape and the surface of that beam, and then I'll pull the gauge over, and then I'll take the gauze pad and I'm just going to wipe it down into place up underneath the gauge. And as soon as I do that, I'm going to take my thumb and put it over top of it, and now we're going to hold it on there a minute. And that's a full 60 seconds. So I've got my watch, I've started, I'm about 15 seconds in, I got about 45 seconds to go. Normally with M-Bond 200, you put a minute of thumb pressure on it, and then you let it sit for 2 additional minutes, and then you're ready for testing. So what we'll do is we'll put the minute of thumb pressure on it, then we'll work on the end of the wire here to get it ready to connect it to a strain indicator, and then we'll go connect it over to a P3. And really you could test it soon as you've waited the 1 minute of thumb pressure, and then you let it sit for 2 minutes. Basically at that point you're ready to test it electrically. In this case, since it's on a composite, you can't really see the resistance to ground, but what you can test for is the installed resistance. The resistance to ground, if you're on metals, is excellent to be able to tell if you've got any issues that could be shorting to the surface of the metal. A lot of times you'll have gauge problems where you'll have a path to ground that could be a wire stripped back too much and it's touching, or it could be some type of conductive material that's left on it. Most likely source of that is flux. And if you test it and you find that you've got some resistance to ground issues, what you should do is go back and re-clean it. And you do that before you put on an environmental coating, because obviously that makes it much tougher to clean it once you started applying a coating system. So I've waited my 1 minute. In order to get my thumb to release, I just take it and turn it like that, and it comes right off. And now what we're going to do is we're going to let it sit for 2 additional minutes, and then we'll take the tape off and then go test it on the P3 strain indicator. Now, the next thing I'm going to do is take the little tie wrap off. And if you look, you can see where the wire has already been partially stripped. So what I'm going to do is just pull that off. and then I'll separate them. The black conductor, pull that down a little bit. They've actually already been separated from us. I'll just kind of pull them apart a little bit more just to give them a little bit more space to connect to the P3. And the other thing that I'm going to do is I'm going to just twist them a little bit, twist them tightly so they'll easily fit into the connector on the P3. It's really that simple and that easy. I think we got 1 more minute for it to sit. You can see where the adhesive flows in and around the solder connections and a little bit in the wire, but it only encapsulates or bonds a little section of that wire onto the beam, so it's a relatively small area. And I just think it makes it neater. Once you take the tape off, you'll see that it typically is a neater installation going this way with the tape than it would be running down along the axis of the wire with the tape. While we're waiting on that, another thing that I can do is add some strain relief for the wire, and I'll go ahead and do that. Very simple. I'm going to take a pair of pointed tweezers and a handle end of a dental pick, and I'm just going to slide it up underneath. I'll slide it down toward the gauge like this and just kind of rock that over. Just make sure you start on the gauge side and go toward, as you rock this over, go toward the free end of the wire. That way when it puts a little tension on the wire, it puts a little tension on the free end. And then once I've formed that little loop in it, I'm just going to tape that in place using a piece of the paper drafting tape. So I'll take about 1.5 inch long piece of it. I'm going to lay it right over top of it, like that. And then just kind of wrap it around. All right, and I think it's time to go ahead and take the tape off the strain gauge. So we've let it sit there a couple of minutes. When you do this, you want to lift the tape, peel it directly back on itself, just like so. And now you could, if you wanted to, go ahead and apply a protective coating. I think we're going to wait. We're going to go check it with the P3 strain indicator. We'll just see how well it's responding. This was really to get some practice of using these new strain gauges on this G10 composite. We do have different sizes of these gauges. This one happened to be a 0.125 inch active length, which is about as small as you'd want to use on a composite. In general, we want to see a little bit more averaging, so we prefer to use more of a 250 size strain gauge. But I think for this weave of composite, I think this would be just fine. If it was a coarser material, for sure I'd use a larger size strain gauge. But let's go test it. So we'll take it off the piece of paper. We're going to slide it into the fixture. And I'm going to remove the gauge that was on there from before. Just turn the P3 on. Now this is a 3-wire quarter bridge, and it's a 350 ohms. So I'm going to go, red wire is going to go to the P plus connection, and then the white wire will be connected to S minus. So I'll take the white wire, connect that to S minus, just like that, and then the black wire will go to D350. So I'll take that, slide that in. You'll notice that now we've got channels 1, 2, and 3 active, and channel 1 is where we've got it connected, and you see we've got an indication. So just to make this easier for me, I'm just going to deactivate channel 2 and deactivate channel 3. Okay, And then the bridge type is set at quarter bridge, which is exactly what we've got. We've got a single active gauge that's quarter bridge. So I'll menu to get back out of that. And for the gauge factor scaling, we said the gauge factor was 2.09. So I'll go down and over. All right, so we're at 2.09. I'll menu to get back out. And right now we've got an initial offset that's really just a function of the resistance tolerance of the strain gauge as well as any wiring. So what I'm going to do is press this balance button to get rid of the offset, and it says, hey, are you ready to really balance? And I have to push it again to make sure that we do want to auto balance it. Record to save it. And now we're at 0. So now we can flex the beam and see what type of response we get. So as I bend it down, you can see I'm loading it in tension, and I let it go. And not bad. It coming back within 1 or 2 microstrains, pretty good for a fiberglass composite beam. Here I go to 7,000 or 700, 800, pushing up around 1,000 microstrain, and then I let it go. And letting it go, you can see that we've got a few counts of initial offset. And those few counts typically are associated with the material properties of fiberglass. It's not going to respond as well as a high strength grade of steel or maybe an aircraft grade of aluminum alloy, just because it is a composite material. I'll load it the other way. Here we're loading it in compression. I'll let it go, and again, it comes back to about 2 microstrains. So as I see that, I think it's working fantastic. Flex it one more time. Very high level of confidence in how well that gauge is bonded. You can see that we went to over 1,500 microstrain and we still had 0 return of just a few counts. So once I'm happy with that, then we'll apply some protective coating on it, and basically we're done. So if we just take the wires out of the P3, turn the P3 off, go back to the workstation, we'll take the beam, lay it down on the piece of paper, and we'll just take our M-Coat C, which is an RTV silicone rubber protective coating. We'll just take a little bit of that and we'll apply it over top of the strain gauge, and we'll chase it down the wires just a bit. And it takes about 24 hours for the stuff to fully cure. So once you get this applied, then by tomorrow afternoon you should be ready for testing. And that's it. And we appreciate you taking a few minutes with us to watch this video and show one of our new advanced sensor strain gauges be installed on a piece of G-10 fiberglass material. If you have any questions about it, feel free to reach out to us. You can call our applications engineering department by dialing 919-365-3800, or you can reach us via email if you just go to the website, which is www.micro-measurements.com. You can contact us through the website as well, and we'd be glad to help you with your strain gauge application.